Okay. Last one, I think, for this week, other than going over what your assignments are, we're going to do a little look at the applications of quadratics. Why are we trying to get you to understand how this stuff works? Because it's out there in the real world. One of the places where we see this is in anything that falls, goes, if you throw something up in the air and trace it out, you find that it goes through a parabola because the effect of gravity is a quadratic component. Um, we're going to have something that's called the acceleration of gravity on Earth, and that is okay. I have it over here. It's negative 9.81 approximately meters per second per second. I'm going to do something else down here, but meters per second, what's that? That is velocity per second. So how fast is the velocity changing every second? That's what acceleration is. When you're in the English, this is the metric number, and this is the English number. I'm going to be honest, we're going to use this one because the factor is a lot nicer. But feet per second, you can see it again. That's velocity, the red's velocity, and per second, that's my time. So how fast is the time changing over time? When you're in a car, and I'll go with the acceleration first, and somebody realizes they're late, and they step on the gas, you can feel the acceleration. That's that little push that's pushing you back. And I hope my physicist friends out there don't start blasting me for this. I'm just trying to get to the meters per second per second. That's the way I like to talk about it. Come to me in BC Calculus. We can talk about this all again, but then we can break it apart into horizontal and vertical components and all that fun stuff. But right now, we're just looking at this. This is one of the reasons that we use these quadratics. So there's that square term. Meters per second squared is the way you hear it often. But how in the heck do you square time? I'll leave you with that concept. But these are the constants for gravity on the Earth. Now, I think it's on this next slide. Yeah, this is the formula for a height of an object that's falling on the Earth. At sea level with standard temperature and barometric pressure, STP. Again, all my physicist friends can blast me for the incorrectness of my lesson, but I'm just trying to show you, a quadratic. Hello, there's a quadratic. That is something that we can figure out. We want to figure out when there's a little person over here and they're going to drop a ball off this side, and we want to find out when is that ball going to hit the ground. Or maybe you're kicking something and you want to find out when it's going to come back to hit the ground. We always end up with a nice little quadratic. So the first part, there's that negative 16. Again, I'm doing this is it would be negative 9.81 if these were all metric. And normally metric units are so much nicer to work with. The power is a 10, but that negative 16 is just such a nice factorable number. I'm going to stay with the English units. And yeah, so if it's feet per second for velocity, or feet per second squared, you use the negative 16. If it's meters, or for the height, or meters per second for the velocity, or meters per second squared, you're going to use that negative 9.81. But this number is always a constant. That's the constant due to acceleration at sea level with temperature and pressure. V of 0, that's called V naught sometimes. That's the initial upward velocity. I'm not going to start breaking this apart for you guys. Come to me in BC Calculus. We can do projectile motion all day long. We can talk about it. It's not that bad. We just got to teach you some trigonometry first. And then this H naught, or H sub 0, is the initial height of the object. So if you're anywhere on Earth, for the most part, you can use this formula to help figure out problems that look like this. So, here we go. Kristen the Daring. Oh, she is so daring. Drops a ball from shoulder height, approximately 4 feet, from the edge of a 60-foot tall building. How long will it take for the ball to hit the ground? Okay, here's our picture. Oop. All right, the same picture we've been dealing with because I didn't want to draw new pictures. Sal, thank you. Khan Academy, I definitely stole that from Sal. So here we go. So the building's height is 60. Yep. And then shoulder height is 4 feet. Sounds about right. So let's see. That's going to make the total height. It's going to be 64 feet. Got it. So now acceleration constant. It was feet. So I know it's going to be that negative 16. Initial upward velocity. We dropped it. When you dropped it, you didn't throw it up, you didn't throw it down. So its initial upward velocity is 0, and the total height is 64. All right. So let's see what we can do with that. Once again, that was a quadratic. So that was my A, B, and C. So negative 16 is my A, the B is 0, and the C is 64. And I could do all the stuff that we talked about to find it, but please notice over here, and I'm picking these numbers that are relatively nice so you can clean up. If you can find a common factor with all these numbers, take it out, and maybe you see there's a 2 goes into each one of them. Okay, yeah, a 4 goes into each one of them. Okay, actually, a negative 16 goes into each one of them. So I'm going to divide all three of these by negative 16. That doesn't change I'm not going to get into it, but that doesn't change the fact. I'm just factoring out a constant. That doesn't change my 0. So if I divide negative 16 by negative 16, I get 1. If I divide 0 by negative 16, I get 0. And if I divide 64 by negative 16, I get negative 4. That just cleans it up a lot. Please know I'm just showing you guys this. I'm not going to be asking you to do this yet. Come back to me in Algebra 2, and you'll be doing this. Okay. What do I get? I do my little X box. I got 1 and negative 4, so I get a negative 4 on the top, and then I get a 0 on the bottom. And what two numbers multiply together to give me negative 4 and add together to give me a 0? There's only one choice. It's 2 and negative 2. So my answers would be, okay, this would be t plus 2, and this would be t minus 2, which means the solution here would be negative 2. The solution here would be 2. But that I don't want to go backwards in time, so I'm just going to take the 2 answer. So it took 2 seconds for the ball to drop to 64 feet. Not long. Doesn't take long to go splat. All right, let's see. Next. All right, Hannah the kicker. Oh, Hannah, good job. She kicks a football off the ground with initial upward velocity of 64 feet per second. I must say, Hannah, if you had an initial upward velocity of 64 feet per second, I think NFL scouts would be coming and talking to you. But again, I'm fixing the numbers so this numbers come out nice. So let's see. Oh, there's my A, B, and C. So again, it's feet. I did this with feet. Yep, feet per second. So there's my negative 16. The initial upward velocity is 64, so the B is 64. And the height, she's kicking it off the ground, so the height is 0. Again, these two have a common factor of negative 16. So if I divide A by negative 16, I get 1. And if I divide the B, the 64 by negative 16, I get negative 4. And I get C is equal to 0. 0 divided by negative 16 is 0. We like 0. Makes the math so easy. So, okay, now let's see. Up in the top, I'm going to get 1 times 0, 0. And on the bottom, I'm going to get that negative 4. And what two numbers multiply together to give me a 0 and add together to give me a negative 4? There's only one thing that multiplies to give you a 0. That's 0. So I have to have 0 in one of the boxes, which puts negative 4 over here. And if we add them, we get the negative 4. So the solution is 4 seconds. You go back and look at some of your NFL films. I promise you, when the kickoff goes, it does not take 4 seconds for the ball to come back down. But again, I'm trying to make nice problems here. All right, let's see. All right, I think that's it. I just wanted to show you guys that. We got one more. Yes, this is the video that's coming after. This is the objects dropping. So I'm the math teacher. I'm not the physics teacher, but I do acknowledge that I love physics because it's math in action. So this is the classic Galileo, I think. That's the Leaning Tower of Pisa, and the way the story goes is that he dropped 2 balls of different masses, let's say a tennis ball and a basketball or a bowling ball, doesn't really matter. He dropped them from the same height, and he observed that they hit at the same time. Now, that's because the acceleration force, this F equals m times a, is force equals mass times acceleration. So the acceleration for both of these things is the same. So they end up falling at the same rate. But the force when they hit is not going to be the same. I'll go with a visual of, imagine, let's go with, I don't know, water balloons. Sure. We'll go with a whole swimming pool full of water balloons down here. And when you drop the balls, when the bowling ball hits, it's going to break more balloons than when you drop the tennis ball, because there's going to be more force involved. So that's my one little aside on the video you're going to watch. But I want you to show the A. That A is that negative 16 or the negative 9.81. That's the acceleration due to gravity. So this stuff does appear in other places.